Hello, my name is Avinash Kumar. Welcome to my channel Stochastic Programming. In this video series, we will talk about latest features released in JDK 14. So let's get started.
JDK 14 was released on March 17, 2020. There are 16 different features which are released in JDK 14. In this video, we will cover 6 most common features. However, for other 10, I'll create separate video. The first feature is pattern matching for instance of operator. This is released as a preview language feature of JDK 14. May be possible in future this feature might be promoted as a standard feature in JDK 15 or maybe 16. Instance of operator is a type of comparison operator because it compares the instance with type. As we can see from this function, we have stored this string in object and we are trying to typecast this object in string. To do so, we are doing three different things. We are checking whether this object is instance of a string. As soon as it returns true, we are creating a local variable, and finally we are trying to typecast this object in string. However, with JDK 14, we can do and achieve the same thing in much more elegant way. Instead of declaring this local variable inside the if block, we can directly declare in the if statement itself. As soon as the instance of operator returns true, JDK it assigns the value in str. And finally, we can use this str variable in our if block.
The next update of JDK 14 is related to helpful null pointer exception. The goal of this feature is to offer helpful information to developers and support folks about the premature termination of the program. Here in this code, when accessing the null referenced object returns null pointer exception. As we can see, from this exception, we are getting three things. One is the function name, file name, and the line number. In the absence of application code or a debugger, this information doesn't exactly pinpoint which object is responsible for causing the exception. However, with JDK 14, we can easily pinpoint which method invoked on the null reference object. So this is the exact message we will get from JDK 14. As we can see, this str is the attribute on which we are calling jar add function. And since this str is null, we are getting this null pointer exception. By default, JDK 14 still returns the old exception message in such scenario. To enable this feature, we need to pass this additional flag in VM options. This is for the purpose of the backward compatibility, because oftentimes there are applications which runs as a sidecar and monitors application logs, exceptions, stack trace, and so forth. The functionality of those applications might not work or might stop working as per the requirements. So in order to enable this feature, we need to explicitly pass this argument. Another good example where this feature can help us to pinpoint exactly which null reference object invoked what method. As we can see from the code, the main objective is to fetch apartment name. In between that, we are accessing multiple nested objects. And guess what? This line of code returns null pointer exception. Now, from this line of code, we are not sure exactly which method is returning the null reference object and which function is invoked on the null reference object. Thanks to JDK 14, now we can clearly see, even without the code, which object returns the null and which function is invoked on null reference object. In this case, it's getStreet is the method which returns the null, and getApartment is the method which is invoked on the null reference object.
The next update is related to switch statements. This is one of the standard feature of JDK 14. Originally, it was a preview language feature in JDK 12 and 13. The main purpose of this switch expression is to extend and use switch statement as an expression or as an statement. Instead of using colon and break statements, we can simply use this arrow operator to write expressive and readable code. The equivalent code for this switch expression prior to JDK 14 was something like this. Here, if you can see, we are writing too many lines of boilerplate code. In JDK 14, we just need to use our arrow operator in order to leverage the same purpose. You might get wondered, what if there are multiple statements and we need to return a single value in JDK 14? How this will achieve with this operator? That's actually a good question, and we can do with this yield operator. So let's say in this case you have multiple statements inside one case, and you can return the simple value using the yield expression.
The next feature is records. Unlike switch expressions, this feature is part of JDK 14 as a preview language feature. Before even discussing records, let's discuss how immutable classes looks like. So as we can see from this slide, this point class contains all the ingredients which an immutable class requires. So we have declared this class as a final. All the attributes are final. In order to initialize the class, the user will use the constructor. There are no setters involved. Also, in addition, we have override equals and hash code so that in future, if someone wants to use this point class as a hash map key, they can easily use. Now, some folks might have this question that we are discussing JDK 14's new feature record. Why we are even discussing this immutable thing here in this slide? This is not an OOP course. Come on, Avinash, what are you doing? Well, guys, you're right, but the thing is, record is actually an immutable class. So it looks something like this. So this is the equivalent implementation, or you can say the alternative way to create an immutable class with JDK 14. Now, the thing is, oftentimes the new developers who actually start developing or writing code in Java, they have this concern that Java is too verbose and writing code in Java is pretty much complex in the sense we have to write all these many lines in order to create simple Pojo. So in Java 14, there is an alternative and pretty straightforward way to declare an immutable class. So as soon as you write the record name with this construct integer x and integer y, you are actually shooting two birds with a single bullet, which means you are declaring your member variables and you have also declared the constructor as well. So this is a normal immutable Java class. So how to initialize and how to use. So as we can see, it is similar to classes. We can create the object with new. We actually pass the value, and in order to access this, we are not required to write any getters. We can directly access with the parameters which we have passed here.
Now, since we are aware that records are nothing but an immutable class, so we can do all the things which we are allowed to do with normal immutable class, which means you can declare generic records. As we can see from this slide, it records can contain static member functions, non-static member functions, static member variables. However, in case of non-static member variables, you can only declare after a record name, and by default they will be private final. Also, just like normal immutable class, you can create an object of record using the new keyword, and directly you can pass the function, the member variables value. In case of inheritance and polymorphism, record obeys same rules, which means you cannot extend record, or records cannot extend any other class. But however, you can implement interface available.
The next feature in JDK 14 is related to text blocks.
You might be wondering, what is text block? A text block is a multi-line string that avoids the need for most escape sequences and automatically formats the string in a predictable way. Here in this example, as we can see, in order to print this code, we need to put some additional characters to format this code as it is on console or maybe in the external file. So this is something which is really hard to read and maintain. In contrast, using three double quote characters, we can declare multi-line string in much cleaner and elegant way. So now you might be wondering why I have used string JDK 13 since it's part of the JDK 14. So that's actually a good question. So originally this feature is actually released in JDK 13. However, improvements suggested in JDK 13 and those improvements are actually part of JDK 14. So the difference between this multi-line string text block in JDK 13 and JDK 14 is of the two escape sequences which are introduced. So here from this example, if you see, I have put some extra spaces. When you compile this code and print on console or any external file, these extra spaces are get removed by JDK. Now, sometimes based on the business requirements, you might need, the extra spaces. So in JDK 14, to achieve this, there is a new escape sequence character is introduced, which is /s. So as soon as you will put /s at the end of the string or the line, JDK 14 will not gonna avoid or remove those extra spaces. Like escape sequence for white spaces, oftentimes for the purpose of readability, we declare strings in a multi-line format. However, during the runtime, we want to consume such string literals in a single line. As we can see from this example, we have wrote a SQL query and we want to consume this as a single line. This is actually good. We can simply use this string. However, when using the similar approach for JDK 13, it implicitly considers this input string as a text block and will print this string in a multi-line fashion. Just like this. Now, this is something which is not required at all. We don't want JDK 13 to consider it as a multi-line string. So in order to avoid this implicit behavior, in JDK 14, there is a new escape sequence for line termination is introduced, that is \. This allows and informs JDK or JVM to not to consider this string as a multi-line, consider it as a normal string and consume as a single line.
The next feature is allied with packaging tool JPackage. This feature is delivered in JDK 14 as an incubator module. So what does this mean? As the name suggested, that provided functionality and exported interfaces are not guaranteed to be stable and may be revised in future releases. So the main motive of this package is to avoid external dependencies which often Java applications required in order to run on any particular platform. So think about it in terms of an application developer. So after creating a jar file, after completing the application, you need to package your components in a native operating system. So like Windows users often aware of this term like MSI or exe file. You cannot directly deliver those jar files to be run on for the purpose of installation. So with this package now, application developers can package their jar files or their application files directly from the native tool itself rather than using third-party dependencies. So based on the requirements, they can create the MSI for Windows user, RPM or APK package for the Linux or the Unix users, and similarly DMG file for Mac OS.